everyone. The position of a particle is given by this equation here. And this is where t is measured in seconds and s is measured in meters. We're going to answer all these questions. We're also going to use the diagram to represent the motion of the article and find the positive and negative direction and find the distance of the particle for the first 5 seconds. So let's get started. The first thing is to find the velocity. So if we let, using this equation here, then the velocity is just going to be velocity of t equals the derivative of s with respect to t. So that's just going to be 3t squared minus 12t plus 9. So that's what they want, the velocity at time t. So they're just asking for the function. So that's that. Now they want to know what is the velocity after 2 seconds, after 4 seconds. So a good way to write this is the velocity of evaluated at 2 equals the derivative of s with respect to t. And you write a line here and say we're evaluating at t equals 2. So you write it like that, and then you fill it in. So that's going to be 3 times 2 squared minus 12 times 2 plus 9. And that's going to equal negative 3 meters per second. And then we're going to do the same thing with the 4. We also have to do 4 seconds. So v of 4 equals derivative of s with respect to t. We're going to evaluate it at t equals 4. So that's going to be 3 times 4 squared minus 12 times 4 plus 9. And that's going to equal 9 meters per second. So that is A and B. Now we're going to determine when is the particle at rest. So when it's at rest, that means v of t equals 0. We also know that v of t equals 3t squared plus 12t plus 9. So what we're going to do is set, these are the same, set them equal to each other. So we have 0 equals 3t squared plus 12t plus 9. And then we solve for t. Let's factor out a 3. We're going to get t squared minus, 4t plus 3. We're going to factor that. So you get t minus 3 and t minus 1. So at 0, our t equals 3 and our t equals 1. All right, so that's when the particle is at rest. Now we're going to move on to D and E. When is the particle moving forward? That's in the positive direction. So basically these are two solutions, and we're going to write this again as 0 equals 3, t minus 1, t minus 3. So we had t equals 1 and t equals 3. Now, we're going to draw a line diagram, and we're starting at 0, and we have t as 1, we have t as 3. So what I want to know is where is that positive and negative. Now, what I can do is just plug in a negative number, or I can plug in 1/2. You could actually plug in 0 in here. When you plug in 0 into this, or 1/2, you're going to get 3 times the positive times the positive. These two will both be positive. So the whole thing will be positive. That's what you put here. Now let's try 2. You plug in 2 in here, you're going to get 3 times a positive times a negative. Because 2 minus 3 is negative 1. That's going to be negative, so we're going to put a negative there. And then above 3, let's try 4. So if we plug in 4, we're going to get 3 times a positive times a positive. That means what I'm doing is I'm plugging in 4 in here. This is going to be positive, positive. So that's going to give you a positive. So the direction that's positive is from 0 to 1 and from 3 to 4. So you could say, if we're not starting at 0, let's just do positive. We can say this is where t is less than 1 and t is greater than 1. Where it's negative is right in here. So that's where t is in between 1 and 3. Okay, remember exactly at 1 and 3, the particle is at rest. Because that's when we set it to 0. So anything in between it, we have positive, at rest, negative, at rest, positive. Now, what they mean by a diagram is we're setting a diagram with S. So we're showing the motion of this particle. So we start with S equals 0. We'll do time equals 0. If t equals 0, so we're starting here because we're not going to do negative time. And you plug in 0, we get S is 0. So we're going to go from positive is from 0 to 1. So I'm going to go from 0 to 1. And I'm going to stop there. And this is I'll just do this as S. So for 0 to 1, I'll put 1 here. So when t is 1, I plug in 1 in here. I'm going to get S is 4. So let's draw the diagram. The diagram is going to be a little different. So you're starting here. And I might have to erase some of this here. I'll move that there. T is less than 1. T is greater than 3. All right, so we start here. We go to here. Now at 1, we're at rest. So this is more of a vertical line because this is going to change directions here. Because now we're moving to negative. So at this point, when t is 1 second, it's at rest, but then it starts moving the opposite direction. So I'm going to draw arrows this way. Now from 1 to 3 seconds, it's negative. So we're going to go back to here, right here. So this is where t is 3. And we're stopped back here. If I plug in 3, I'm back at S equals 0. I'm going to move this up. Sorry. So t equals 3 and S equals 0. And at t equals 0, we're at rest. So you move back up. And then at this place, then we start moving with if t equals 3, it starts going positive. So go back this way. And it keeps going on because all this will be positive. So you have your arrows this way. This is negative. And then this goes back to positive. And that's how you would draw the diagram. So we have our 3, t equals 0, t equals 1, and t equals 3. I had to squeeze up there. That's our main points here. All right, and our S's, this is our S graph. Our S equals 0 right in here, and S equals 4 right in here. So I could do 1, 2, 3, 4. All right, so that's the diagram. Now what do we have to do? Find the total distance traveled by the particle during the first 5 seconds. So what we're going to do is we're looking at the distance, is you're looking at the intervals from 0 to 1, and then we have to go, that's where it's positive, from 1 to 3, and then after 3, it's positive, but they only want us to go the first 5 seconds to 5. And what you're going to do is just take f of 1 minus f of 0. And you do the absolute value because we're talking about distance. So f of 1, if I plug 1 in here, I'm going to get 4. So it's going to be 4 minus, if I plug in 0, I get 0. So this equals 4. Now let's do the next one. Absolute value of f of 3 minus f of 1. Now we already did f of 3 when we did the other one. So f of 3, when you plug in 3 in here, our s was 0. So that's going to equal absolute value of 0 minus f of 1, we already did that, 4. So absolute value of negative 4 equals 4. All right, and then we have to do f of 5 minus f of 3. So f of 5 is going to be 20. So if you plug in 5 in here, you'll get 20. So that's 20, and f of 3 we already know is 0. So that equals 20. Now, so find the total distance as you just add these up. So we have 4 plus 4 plus 20 equals 28. And that's going to be meters. All right, next one, acceleration at time t after 4 seconds. So to get the acceleration, basically all you're doing is you're taking the second derivative of this. So basically what was that? You can just take your velocity of t. So what is that? That's 3t squared minus 12t plus 9. So your acceleration of t is just the derivative of your velocity. So that's going to be 6t minus 12. And then they ask at 4 seconds. So basically, we're going to get our acceleration is, or we can do a sub 4, a of 4 is 6 times 4 minus 12. For your acceleration, it's always squared, so that's going to be 12 meters seconds squared. Now, they want us to graph the position, velocity, and acceleration all in the same graph. So I already did that to save some time on this. You can use your calculator. What you really want to look at is your y-intercepts. So for s, the y-intercept was 0. For velocity, the y-intercept was 9. And for your acceleration, the y-intercept was 12. And then they want it from 0 to 5. So make your calculator window, do that, and just graph them all via the calculator. And it should look something like that. That's it. Thank you. Have a nice day. Bye-bye.